The morning air inside Interrogation Room 7 at Camp Clinton, Mississippi, carried the stale smell of cigarette smoke and floor wax. It was March 8, 1945, and Hauptmann Werner Schulze sat across a metal table from an American intelligence officer trying to process what he had just been shown. The photographs spread before him depicted row after row of M3 half-tracks rolling off assembly lines, their white stars gleaming under factory lights. According to the typed caption, these images were from a single shift at the White Motor Company plant in Cleveland, Ohio. One shift, 37 vehicles. The American officer leaned back in his chair, watching the German engineer's face for reaction. Schulze, who had spent 4 years designing suspension systems for Germany's SDKFZ series at the Bussing-Nag plant in Brunswick, said nothing at first. He simply stared at the photographs, his fingers drumming once against the table edge, then stopping. When he finally spoke, his English was careful, his voice quiet. "This is not possible," he said. "Not with quality control, not with precision. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today." The American officer smiled slightly and slid another folder across the table. Inside were production statistics that would fundamentally alter Schulze's understanding of industrial warfare. In 1943 alone, American manufacturers had produced over 41,000 half-tracks. Germany, by comparison, had manufactured approximately 23,000 of all types of half-tracked vehicles during the entire war. The numbers represented more than a production gap. They represented two completely different philosophies of engineering, two incompatible visions of what a military vehicle should be, and ultimately, two nations whose industrial capabilities existed in entirely separate categories of possibility. Werner Schulze's journey to that interrogation room had begun 31 months earlier, in the autumn of 1942, when he had been transferred from his position as a junior automotive engineer at Daimler-Benz to the military vehicle development program at Bussing-Nag. Germany's half-track program was, at that time, considered among the most sophisticated in the world. The SD KFZ-151 series, which would become the standard German armoured personnel carrier, represented years of careful engineering refinement. Each vehicle featured a complex suspension system with individually sprung road wheels, precision-machined drive sprockets, and a sophisticated steering mechanism that allowed for remarkably smooth cross-country performance. Schulze had been proud of his work on these vehicles. The technical challenges were substantial. Unlike wheeled vehicles, half-tracks required careful balance between the front steering wheels and rear tracks, demanding precise weight distribution and suspension geometry. The German solution involved interleaved road wheels, overlapping armor plates, and finely tuned torsion bars that absorbed shock across rough terrain. A single SD KFZ 151 required approximately 2,500 man-hours to complete, with tolerances measured in fractions of millimeters. Quality control inspectors checked every weld, every bearing surface, every mechanical linkage. The result was a vehicle that could traverse obstacles American trucks could not approach, that could maintain formation across Belgian forests and Russian steppes, that embodied the principle of German engineering excellence. This principle was not merely nationalist pride. It emerged from Germany's specific industrial constraints and military doctrine. With limited raw materials and manufacturing capacity compared to potential enemies, German military planners had concluded that superior quality could compensate for inferior quantity. A single German half-track, properly engineered, could outperform 3 inferior vehicles. A German tank battalion, though smaller than its Allied equivalent, could achieve victory through technical superiority and tactical innovation. This logic had guided German rearmament throughout the 1930s and into the war itself. It was doctrine, strategy, and identity, all forged into steel and rubber. The men who designed these vehicles believed absolutely in this approach. Schulze's education at the Technische Hochschule in Berlin had emphasized precision, mathematical rigor, and the pursuit of optimal solutions. His professors spoke of engineering as a craft, requiring years of apprenticeship and masterful understanding of materials science. When Schulze examined American vehicle designs in captured technical manuals during 1943, he had been genuinely puzzled by what he found. The American M3 half-track seemed almost primitive by comparison to German standards. Its suspension used simple volute springs instead of sophisticated torsion bars. The tracks themselves were rubber-soled and relatively lightweight, suitable for roads but questionable for serious cross-country work. The armor was thin, barely adequate against small arms fire. Most striking was the apparent lack of precision in manufacturing tolerances. Components seemed designed for rapid assembly rather than optimal performance, with large clearances and simplified connections. To Schulze and his colleagues, this represented a failure of engineering imagination. The Americans, despite their vast industrial capacity, appeared unable or unwilling to pursue genuine mechanical excellence. Their vehicles were adequate, perhaps, but they lacked the refined sophistication that German engineers considered essential. This perception was reinforced by reports filtering back from the Eastern Front. German commanders noted that while Soviet forces possessed numerical superiority, German vehicles consistently outperformed their counterparts in mobility, reliability, and combat effectiveness. The same appeared true in North Africa and Italy. American equipment was present in enormous quantities, certainly, but individual German vehicles demonstrated clear technical advantages. What Schulze could not see from his drafting table in Brunswick was the strategic calculation occurring in Detroit, Cleveland, and dozens of other American industrial centers. While German engineers pursued perfection, American production managers pursued something entirely different: scalable volume. The philosophical difference was fundamental. Where Germans asked, "How can we make the best possible vehicle?" Americans asked, "How can we make adequate vehicles faster than the enemy can destroy them?" This was not a question of engineering capability. American engineers understood precision manufacturing as well as their German counterparts, but they had chosen a different path, one that prioritized production speed, parts interchangeability, and manufacturing simplicity over individual vehicle performance. The M3 half-track embodied this philosophy completely. Designed by the White Motor Company and standardized by the U.S. Army in 1941, the vehicle was intentionally simplified for mass production. Its suspension system used commercial truck components wherever possible. The volute spring design, though less sophisticated than German torsion bars, could be manufactured quickly by firms with no previous military experience. The track design sacrificed some cross-country performance for reliability and ease of replacement. Most critically, the entire vehicle was designed around the concept of interchangeable parts. Any M3 component could be removed and replaced with a part from any other M3, regardless of which factory had produced either vehicle. This standardization extended across the entire American military vehicle fleet, allowing for unprecedented logistics efficiency. By the time Schulze was captured during the Battle of the Bulge in January 1945, American factories had refined this mass production approach to extraordinary levels. The White Motor Company's Cleveland plant could complete an M3 half-track in approximately 60 hours of labor, less than 3% of the time required for a comparable German vehicle. This was achieved through assembly line techniques adapted from civilian automobile production, with specialized workers performing repetitive tasks rather than craftsmen building complete vehicles. The result was not a better half-track in terms of individual performance. German vehicles remained superior in cross-country mobility, comfort, and mechanical refinement, but American factories could produce 15 M3s in the time Germany produced one SDKFZ 151. And in total warfare, that mathematical reality superseded all questions of engineering elegance. Schulze's capture had occurred during the final, desperate days of Operation Wacht am Rhein, Germany's last major offensive in the West. His unit, a reconnaissance company attached to the 2nd Panzer Division, had been surrounded near the town of Mannheim in Belgium. The fighting had been chaotic, with American forces counter-attacking through heavy snow. What Schulze remembered most clearly was not the combat itself, but the aftermath. As his company withdrew through frozen forests, American supply columns were already moving forward along cleared roads. Half-tracks, trucks, jeeps, all in seemingly endless procession, moving with mechanical efficiency through terrain German forces had struggled to traverse. The vehicles were functional rather than impressive, their crews casual rather than parade ground sharp. but their sheer number conveyed a message more powerful than any propaganda broadcast. America was not fighting a war of attrition. America was fighting a war of industrial abundance. The journey from the Ardennes to Camp Clinton took 6 weeks. Schulze and several thousand other German prisoners were first processed through camps in France, then loaded onto Liberty ships for transport across the Atlantic. The crossing took 12 days, during which the prisoners were confined below decks with minimal information about their destination. When they finally disembarked at the port of New Orleans on February 24, 1945, Schulze experienced his first direct encounter with American industrial scale. The port facilities stretched for miles along the Mississippi River, with dozens of ships being simultaneously loaded and unloaded. The Liberty ships themselves, Schulze learned from a guard, were being produced at a rate of 3 per day across American shipyards. 3 ships per day, each capable of carrying 10,000 tons of cargo. The mathematics were staggering. In the time it took Germany to complete a single heavy cruiser, America launched enough merchant shipping to transport an entire army group with all its equipment and supplies. This was industrial capacity operating at a scale Schulze had never conceived possible. It was not a matter of superior engineering. It was a matter of systematic organization, resource allocation, and manufacturing philosophy extended across an entire continental economy. Camp Clinton itself was relatively comfortable compared to the conditions Schulze had endured during the final months on the Western Front. The prisoners were housed in wooden barracks, fed regularly, and allowed limited recreation. The American authorities separated officers from enlisted men and further divided prisoners by specialty. Engineers, technicians, and skilled workers were identified and housed together, ostensibly for administrative efficiency, but actually for intelligence purposes. The Americans were systematically debriefing German technical personnel, gathering information about manufacturing processes, design philosophies, and engineering capabilities. These interrogations were not harsh or threatening. They were methodical, professional, and disturbingly thorough. Schulze's first interrogation occurred on March 3, 1945, 5 days after his arrival at Camp Clinton. The intelligence officer, a captain named Holbrook, who spoke excellent German, began with routine questions about unit composition, chain of command, and recent operations. Then the conversation shifted to technical matters. What was Schulze's exact role at Büsing-Nag? Which specific systems had he worked on? What were the production bottlenecks? How did German engineers approach the problem of limited raw materials? The questions were knowledgeable, indicating that Captain Holbrook had significant technical training or access to experts who did. Schulze answered carefully, providing information he believed the Americans likely already possessed, while avoiding specifics that might compromise German capabilities. But on March 8, the interrogation changed character entirely. Captain Holbrook arrived with the folders of photographs and production statistics that would fundamentally alter Schulze's understanding of the war he had been fighting. The images showed American factories operating at capacity, assembly lines moving with choreographed precision, finished vehicles rolling out of plants in Cleveland, Detroit, and Grand Rapids. The statistics detailed not just half-track production, but the entire American military-industrial output. Tanks, aircraft, trucks, artillery pieces, all being manufactured at rates that exceeded Germany's total production by factors of 5, 10, or 20, depending on the specific weapon system. Schulze's initial response, his quiet statement that such production rates were impossible with quality control, reflected genuine disbelief rather than propaganda-induced denial. As an engineer, he understood the technical constraints of precision manufacturing. He knew the time required to machine components to proper tolerances, the complexity of assembly processes, the necessity of thorough inspection procedures. What Captain Holbrook was showing him simply did not fit within that engineering framework. It suggested that the Americans had somehow bypassed fundamental manufacturing limitations, that they had discovered methods German engineers had not considered. Captain Holbrook explained patiently. The key was not individual vehicle quality, but systematic standardization. American factories did not build vehicles from the ground up with custom-fitted components. They assembled vehicles from interchangeable parts produced by dozens of different suppliers, all manufactured to consistent specifications that allowed adequate performance with minimal precision. A German half-track suspension system required components machined to tolerances of plus or minus 0.05 mm. An American system used tolerances of plus or minus 0.5 mm, 10 times less precise, but adequate for the vehicle's intended use and infinitely faster to produce. This represented not inferior engineering but different engineering, optimized for a different strategic purpose. The implications were staggering. If American factories could produce vehicles with 1/10 the precision and 1/20 the labor input, then Germany's carefully cultivated technical superiority was strategically irrelevant. A German half-track might indeed be superior to an American M3 in cross-country performance, mechanical refinement, and crew comfort. But if 20 M3s could be produced for every German vehicle, and if those M3s were adequate for their tactical purposes, then German engineering excellence had become a strategic liability. Germany was investing vast resources and precious time creating superior individual weapons, while America was creating adequate weapons in overwhelming numbers. This was the industrial equivalent of bringing a precision rapier to a battle against massed musket fire. Schulze asked to see the photographs again. He examined them more carefully, looking for evidence of forgery or manipulation. The images appeared genuine. The factory settings were consistent, the vehicles properly detailed, the production line layout logical and efficient. He recognized some of the manufacturing techniques from his own training, adapted and scaled up to extraordinary levels. Captain Holbrook watched him silently, allowing the German engineer time to process what he was seeing. Finally, Schulze looked up and asked a different question, not about the photographs, but about the mathematics underlying them. "How many workers?" he asked. "Does your White Motor Company plant employ?" Captain Holbrook consulted his notes. "Approximately 15,000, he said, at the Cleveland facility alone, plus thousands more at supplier facilities producing components, engines, transmissions, tracks, armor plates. The entire supply chain involved hundreds of companies, many of which had never manufactured military equipment before 1941. They had been civilian firms producing automobiles, agricultural equipment, household appliances. They had converted to military production using the same mass manufacturing techniques they had developed for civilian markets. This was America's secret advantage, Captain Holbrook explained. Not superior engineering, but superior industrial organization. The ability to rapidly convert peacetime manufacturing capacity to military production, to coordinate thousands of suppliers through standardized specifications, to train unskilled workers to perform specialized tasks quickly and reliably. For Schulze, this represented a fundamental inversion of everything he had been taught about industrial warfare. German military doctrine emphasized the importance of technical excellence precisely because Germany lacked the raw industrial capacity of potential enemies. Superior weapons, properly employed, could compensate for numerical inferiority. But what if numerical superiority was not merely a matter of having more factories or more workers? What if it was a matter of organizing industry according to entirely different principles? What if the Americans had developed a form of manufacturing that made German-style precision craftsmanship strategically obsolete? The interrogation continued for another hour. Captain Holbrook showed Schulze additional evidence of American production capacity, photographs of tank factories, aircraft plants, shipyards, statistics on steel production, aluminum refining, rubber synthesis. Charts showing the exponential growth in American military output between 1941 and 1944. Every data point reinforced the same terrible conclusion. Germany was not being defeated by superior Allied generalship, though Allied commanders were certainly competent. Germany was not being defeated by Allied soldiers, though they fought effectively. Germany was being defeated by Allied factories, by industrial systems operating at scales and with efficiencies that German engineers had not imagined possible. When the interrogation ended, Schulze was escorted back to his barracks. He spent that evening sitting on his bunk, staring at the wooden wall, trying to reconcile what he had learned with everything he had believed about Germany's chances for victory. He thought about his colleagues still working at Bussing Nag in Brunswick, Still designing increasingly sophisticated suspension systems for vehicles Germany could no longer produce in meaningful numbers. He thought about the Tiger tanks, marvels of engineering that required so much time and so many specialized materials that Germany had managed to build only about 1,300 during the entire war. He thought about the carefully crafted arguments he and his fellow engineers had made throughout the 1930s, about how quality could triumph over quantity, about how German technical excellence would prove decisive in any future conflict. All of it, he now understood, had been based on a fundamental miscalculation about the nature of industrial warfare in the 20th century. German engineers had optimized for individual vehicle performance, while American engineers had optimized for systematic production volume. Neither approach was inherently superior in engineering terms, but one approach was superior strategically, and that approach had been developed not in engineering schools but in automobile factories, where American manufacturers had spent decades refining the techniques of mass production. Henry Ford's assembly line, refined and scaled up to military production, had proven more decisive than any German technical innovation. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Over the following weeks at Camp Clinton, Schulz had opportunities to discuss these realizations with other German technical personnel. The conversations were careful, coded with the awareness that guards might be listening, but the themes were consistent. German engineers and officers who had encountered American industrial output firsthand were coming to similar conclusions about the war's outcome. Some, like Schulz, approached it as a technical problem, analyzing the manufacturing philosophies and production systems that had created such disparity. Others viewed it more emotionally, as a betrayal of the principles they had been taught about military excellence and national capability. But all of them recognized that something fundamental had shifted in their understanding of modern warfare. One conversation particularly stood out in Schulz's memory. It occurred in early April, several weeks after his initial interrogation with Captain Holbrook. Another prisoner, Oberstleutnant Hans Dietrich, had been a logistics officer with the 6th Panzer Army during the Ardennes offensive. Dietrich had spent years managing supply chains, calculating fuel consumption rates, and projecting equipment replacement schedules. He understood better than most combat officers the material realities underlying German military operations. During the Battle of the Bulge, Dietrich had watched German armored divisions run out of fuel within sight of American supply dumps, unable to advance not because of enemy resistance, but because Germany's logistics system could not sustain offensive operations over extended distances. Meanwhile, American forces moved freely, supplied by endless columns of trucks carrying fuel, ammunition, food, and replacement equipment. Dietrich expressed it bluntly. "We were fighting a 19th century war with 20th century weapons," he said. "The Americans were fighting a 20th century war with 20th century industry." The distinction seemed subtle, but was actually profound. German military doctrine still conceived of warfare in terms of decisive battles, brilliant maneuvers, and technical superiority. These were the principles that had guided Prussian and German military thinking since the era of Frederick the Great. American doctrine, by contrast, treated warfare as an industrial process, to be won not through brilliance, but through systematic application of overwhelming material resources. It was, Dietrich suggested, the difference between thinking of war as an art and thinking of war as a science of resource management. Schulz found this framework helpful for understanding his own experience at Büsing-Nag. German engineers had approached half-track design as a craft, seeking optimal solutions through careful analysis and skilled execution. American engineers had approached the same problem as a manufacturing challenge, seeking adequate solutions through standardized processes and scalable production. Neither approach was wrong in absolute terms, but they served different strategic purposes. Germany's approach made sense for a nation with limited resources, seeking to maximize the effectiveness of each individual weapon. America's approach made sense for a nation with vast resources, seeking to overwhelm enemies through material abundance. The tragedy, from Schulz's perspective, was that German leadership had failed to recognize which approach was appropriate for total warfare against industrial nations. In a limited conflict, where victory could be achieved quickly through technical superiority and tactical excellence, the German approach might have succeeded. But in a protracted struggle against enemies with superior industrial capacity, Germany's focus on precision manufacturing had become a liability. Every hour spent perfecting the design of a single vehicle was an hour not spent producing 10 adequate vehicles. Every component machined to exquisite tolerances was a component that required specialized machinery and skilled labor that could have produced multiple simpler components. German engineering excellence had become, paradoxically, an obstacle to military effectiveness. This realization was particularly bitter for Schulze, because it was not a realization about German incompetence or Allied superiority in some absolute sense. It was a realization about strategic misalignment. German engineers were highly skilled. German factories were technologically advanced. German military planning was sophisticated. But all of that skill, technology, and planning had been directed toward the wrong objectives. Germany had been trying to out-engineer its enemies when the actual requirement was to out-produce them. It was as if Germany had entered a marathon while training for a sprint. The training itself was excellent, the athletes were capable, but they had prepared for the wrong competition. During May 1945, as news of Germany's surrender filtered through Camp Clinton, these technical discussions took on additional emotional weight. The war was over. Germany had been defeated completely. All the sophisticated weapons, all the technical innovations, all the engineering excellence that Schulze and his colleagues had devoted their careers to developing had proven insufficient. The final casualty figures were still being compiled, but it was already clear that millions had died in a conflict that Germany had no realistic chance of winning once the United States entered with its full industrial capacity. Some prisoners responded to this reality with denial, insisting that Germany had been defeated by treachery, by overwhelming numbers of inferior troops, by anything except the simple material fact of industrial inadequacy. Others responded with relief that the killing had ended, regardless of the outcome. But for Schulze and other technical personnel, there was an additional layer of response, a professional reckoning with the role they had played in prolonging a war that could not be won. They had designed weapons believing that technical superiority mattered. They had advocated for complex, precision-engineered vehicles, believing that quality could compensate for quantity. They had, in essence, provided German leadership with technical justifications for continuing a strategically hopeless struggle. This was not a comfortable realization. Schulze had not been a Nazi Party member, had not been involved in war crimes, had simply been an engineer doing his job to the best of his ability. Yet his work had contributed to the war effort, and the questions of responsibility could not be easily dismissed. If German engineers had understood earlier that American industrial capacity made victory impossible, could they have communicated that to military leadership? Would it have made any difference? Or was the war fundamentally driven by ideological commitments that no amount of technical reality could have altered? These questions had no simple answers, but they weighed heavily on Schulze during his time at Camp Clinton. He spent much of the summer of 1945 working in the camp's administrative offices, translating German technical documents for American intelligence officers. The work was tedious, but allowed him access to additional information about American industrial capacity. He learned about the U.S. synthetic rubber program, which had replaced access to natural rubber supplies and enabled tire production at scales Germany never approached. He learned about the expansion of American steel production, the development of new alloys, the mobilization of women workers into factories, the coordination of thousands of private companies through government contracts and standardized specifications. Each piece of information reinforced the central lesson of his March interrogation with Captain Holbrook. America had not won the war through military genius or technological breakthrough. America had won through systematic industrial organization, through the unglamorous work of supply chain management, production scheduling, quality control, and logistics coordination. These were not the subjects that captured imagination or inspired patriotic sentiment, but they were the actual mechanisms of victory in industrial warfare. Germany had lost not because German soldiers were inferior or German weapons inadequate, but because German industry could not match the systematic efficiency of American mass production. By the time Schulze was repatriated to Germany in September 1946, more than 18 months after his capture, his understanding of engineering and warfare had been fundamentally transformed. He returned to a nation in ruins, where his professional skills were desperately needed for reconstruction, but where the military industries he had devoted his career to no longer existed. Büsing-Nag had been destroyed by Allied bombing. The remaining German automotive industry was being reorganized under Allied occupation authorities, focused on civilian production rather than military vehicles. Schulze found work at a small engineering firm in Hamburg, designing agricultural equipment and light commercial vehicles. It was a dramatic come-down from his previous position, but it allowed him to use his technical skills while Germany slowly rebuilt. He never spoke publicly about his experiences during the war, maintained minimal contact with former colleagues, and focused his energy on the practical problems of peacetime manufacturing. But the lessons he had learned at Camp Clinton never left him. When he trained younger engineers in the 1950s and 60s, he emphasized not just technical excellence, but also manufacturing practicality, production efficiency, and the importance of designing for scalability rather than perfection. The American M3 half-track that had so puzzled Schulze in 1943 continued in service with the U.S. military until the 1980s, eventually being replaced by the M113 armored personnel carrier. Over 41,000 M3s were produced during the war, serving not just with American forces, but being supplied to Allied nations through Lend-Lease programs. Their design was never cutting-edge, their performance never exceptional by German standards, but their sheer numbers and reliability made them one of the most successful armored vehicles of the Second World War. The German ST, KFZ, series vehicles that Schulze had worked on were technically superior in many respects, but less than 15,000 of the 151 model were produced during the entire war. That numerical disparity, more than any technical specification, told the story of two different approaches to industrial warfare and which approach proved decisive. The broader implications of this production disparity extended far beyond half-tracks. American factories produced over 88,000 tanks during the war, compared to approximately 50,000 for Germany. American aircraft production exceeded 300,000 planes, dwarfing Germany's approximately 119,000. American shipyards launched over 6,000 vessels, including escort carriers, destroyers, and thousands of Liberty ships. Every category of military equipment showed similar disparities, all reflecting the same fundamental difference in industrial philosophy and capability. German generals and military historians would spend decades after the war analyzing the reasons for defeat. Many focused on strategic errors, such as the decision to invade the Soviet Union or the declaration of war against the United States. Others emphasized tactical mistakes or the personal failings of Adolf Hitler as supreme commander. These analyses were not wrong, but they often overlooked the underlying material reality that men like Werner Schulze came to understand during their time in American prisoner of war camps. Regardless of strategy or tactics, Germany could not win a protracted industrial war against enemies whose combined production capacity exceeded German capabilities by factors of 5 to 10. The outcome was determined not by battles but by factories, not by generals but by production managers, not by tactical brilliance but by supply chain efficiency. This was the truth that Schulze had confronted in Interrogation Room 7 at Camp Clinton on March 8, 1945, when Captain Holbrook showed him photographs of American half-tracks rolling off assembly lines at rates German engineers considered impossible. It was a truth that shattered his understanding of engineering excellence, military capability, and the nature of modern warfare. German engineers had not been wrong to pursue technical sophistication, but they had been serving a strategic vision that misunderstood the fundamental character of industrial warfare in the 20th century. Quality could not defeat quantity when quantity was adequate for the task and available in overwhelming abundance. Werner Schulze lived until 1983, long enough to see Germany rebuilt as an economic powerhouse, its automotive industry once again among the world's most respected. The Mercedes-Benz, BMW, and Volkswagen vehicles of the post-war era embodied many of the same engineering values Schulze had pursued at Büsing-Nag: precision, quality, and technical excellence. But they were civilian vehicles now, competing in peacetime markets where such values were commercially advantageous rather than strategically counterproductive. Schulze never lost his appreciation for engineering elegance, but he also never forgot the lesson he learned at Camp Clinton. Excellence matters, but so does context. The best solution depends not just on technical capability but on strategic requirements, resource availability, and the specific constraints of the problem being solved. The half-tracks themselves, both American and German, eventually became museum pieces and collector's items, artifacts of a particular moment in military-industrial history, but the fundamental tension they represented, between quality and quantity, between precision and scalability, between craft, tradition, and mass production, remained relevant long after the war ended. It was a tension that shaped manufacturing philosophy, military procurement, and engineering education throughout the Cold War and into the 21st century. Every generation of engineers faced some version of the same question Schulze had confronted. When is good enough actually better than perfect? The answer was never simple, but the consequences of getting it wrong could be profound. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.